adjoint and the inverse of a matrix. Adjoint and inverse of matrix. So here we are going to learn about the adjoint and the inverse of matrix, that is a square matrix of 2 cross 2 and 3 cross 3 matrix. The definition of adjoint of a matrix, that is the adjoint of a square matrix. Adjoint is always for the square matrix. So the adjoint of a square matrix A equal to Aij and n cross n, because it is on cross n, because it is a square matrix, is defined as the transpose of the matrix Aij. This is capital A, this is the small Aij, that is the element, capital Aij, that is the cofactor of a matrix n cross n, where Aij is the cofactor of the element Aij. Adjoint of the matrix A is denoted by adjoint of A. So first I am going to deal with the 3 cross 3 matrix. So to find the adjoint of the matrix for a 3 cross 3 matrix, this is the matrix A. It is a 3 cross 3 matrix. So these are the element A11, A12, A13, A21, A22, A23. These are the element A31, A32, this is 32, A33. So adjoint of A will be adjoint of A. So it is a cofactor of, so cofactor of A11, that is capital A1, cofactor of A12, capital A12, A13. This is a cofactor. A21, capital A21, capital A22, capital A23, capital A31, capital A32, capital A33, and transpose. Means what do you mean a transpose? Transpose means when the row became the column and column became the row, that is the transpose. So the row will become column. So it will be A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the adjoint of the matrix. So these are the cofactor, and after the cofactor find a transpose of this. So this is the adjoint of the 3 cross 3 matrix. For the 2 cross 2 matrix, it is a little bit different. So for this is for 3 cross 3 matrix. Now for 2 cross 2 matrix. 2 cross 2 matrix, for the 2 cross 2 matrix, the matrix element 1, A11, A12, A21, A22. These are the matrix. So adjoint of A, it find directly, that is interchange these two. So it will be A22, A11. Then change the sign. So this is positive and positive. So these two will be negative. Negative A12, A21, negative. So this is the adjoint of 2 cross 2. This is the adjoint of the 3 cross 3. Only we need this. Now after the adjoint, we have the theorem, that is theorem 1.1. It states that this is the theorem. If A be any given square matrix, if it is a given square matrix of order n, then A into adjoint of A is equal to adjoint of A into A is equal to determinant into I. So if we take the matrix A and find the adjoint of this, if you multiply A into adjoint will be equal to adjoint into A, adjoint A into A, so equal to determinant into I. I is the identity matrix. So these three will be equal. So this is the first theorem. Only explanation is required. Now another we have theorem 4. What does the theorem 4 states that? That is a square matrix. Here always in the determinant we are going to deal with a square matrix. What is a square matrix? The square matrix is a matrix when its row and column is equal, that is a square matrix. So A square matrix A is said to be singular. When a matrix is said to be singular, if its determinant is equal to 0. If its determinant is equal to 0, that will be the square, that will be the singular. Now what is a non-singular? Non-singular also, okay. Non-singular. A square matrix A is said to be non-singular if a determinant of A is not equal to 0. If equal to 0, this is singular. If A is not equal to 0, that is non-singular. Now theorem 2. Theorem 2 states that if A and B are non-singular matrix of the same order, then AB and BA are also non-singular matrix of the same order. Means if we take the A matrix and B matrix that is non-singular, then their product, AB is the product of AB or the BA will be also, that will also be a non-singular. That is a theorem 2. Then we have theorem 4. This is theorem, or theorem 3 is left. Theorem 3. The determinant of the product of the matrix is equal to the product of their respective determinants, that is AB determinant equal to A determinant into B determinant, where A and B are square matrix of the same order. So here you will take the two square matrix of the same order. I mean, let's do 2 cross 2 matrix or a 3 cross 3. Only there is a 3 cross 3 and 2 cross 2 matrix. So if the determinant, if the product these two are non-singular, both are first, it have to be a, so AB, if you multiply the two matrix and find the determinant, that will be equal to, if you find the determinant separately and multiply it, that result will be equal. So that is the theorem 3. If we have the AB matrix, multiply AB and find the determinant, that will be equal to, first find the determinant of AB separately and multiply, that too will be equal. That is theorem 3. Now theorem 4. Theorem 4 states that A square matrix A is invertible. When a matrix is said to be invertible, if it is a, if and only if A is a non-singular matrix. Means if a matrix is non-singular, then it will have the invertible. If it is a invertible, if and only if means if it is a invertible, it have to be non-singular. If it is a non-singular, it is a invertible. That is a if and only if. And the meaning of if and only if. A square matrix A is invertible. A matrix is invertible if and only if A is a non-singular. So first we will have, if we have the matrix, find the determinant of it, determinant of the matrix. If the determinant is does not equal to 0, then it has a inverse. So now what is the inverse formula? Inverse of the matrix. If the determinant is the first, for the inverse of the matrix, inverse matrix, it can be 2 cross 2, it can be 3 cross 3. First we have the matrix A. We are going to say, does it have the singular or non-singular? A does not equal to 0 means non-singular. Non-singular. If it is non-singular, so in A inverse is inverse. This is the symbol of A inverse. Is equal to adjoint of A. We need the adjoint divided by determinant of A. So this is the formula for finding the A inverse. A inverse is equal to adjoint of A divided by determinant of A. So all the theorem and definition is complete. Now it's come now for the exercise. First question. Find adjoint of the each of the matrix, that is exercise question number 1 and 2. So question number 1 is 2 cross 2, question number 3 is a 3 cross 3 matrix. We have to find the adjoint of the matrix. For finding the adjoint, we need a cofactor. So first is the 2 cross 2. 2 cross 2 is easy. Exercise. Exercise, that is 4.4. 4.4. Question number 1. Matrix is given, so I am going to consider as a matrix A. 1, 2, 3, 4. This is the matrix A. I am going to find it adjoint. Adjoint of this matrix. This is 2 cross 2 matrix. Adjoint of A. Interchange these two diagonal, these two positions. So it will be 4. Here it will be 1. Now change the sign of these two. -2, -3. So this is the 2 cross 2 matrix. Adjoint of 2 cross 2 matrix. Now for the 3 cross 3 matrix. 3 cross 3 matrix, it's a little bit complicated. We have to find the adjoint of each element. So question number 2. Let's consider this is a matrix A. So it will be 1, -1, 2, 2, 3, 5, -2, 0, 1. This is the matrix. So we need a A11 to win all the cofactor. That is A11. First, what is the formula of A1? Aij. Aij equal to -1 power I plus j mij. So Aij means A11. A11, that is -1 power 1 plus 1 M11. Now -1, this will be positive. So 1 into M11, eliminate first row, first column. So it will be 3, 0, 5, 1. 1 into 3 minus 5 into 0, 0. 1 into 3 is equal to 3. A12 -1, 1 plus 2, M12. This will be minus negative 1 into, eliminate first row and second column. 2 minus 2, 5, 1. -1 into bracket 2 minus by minus plus 5 to the 10 is equal to -1 into 12 is equal to -12. Capital A13 -1 1 plus 3. Now it will be plus again 4, 3 plus 1 4. M13, it will be positive into M13, eliminate first row and third column. 2, 3 minus 2, 0. So it will be positive into determinant 0 minus will become plus, it will be 6 is equal to, it will be 1 into 6 equal to 6. Now A21 -1 power 2 plus 1 M21 is equal to 2 plus 1 3, so it will be negative 1 modulus. Okay, determinant of, eliminate second row and first column. Second row, this is the second row and first column. -1 2 0 1, -1 2 0 1. So -1 bracket -1 -0, so it will be -1 into -1 equal to 1. Next A22, eliminate the second row and second column. Second row and second column. 1 minus 2, okay, first -1 2 plus 2 M22. This will be plus, so 1 minus 2, this 1 minus 2 minus 1 0 2, eliminate this row and this column, second row, this row and this column. So it will be 1 minus 2 2 1, so it will be 1 bracket 1 plus 2 to the 4, 1 into 5, so that is 5. Now A23 that is -1 power 2 plus 3 M23 is equal to, it will be 3 4 5, it will be -1, bracket, eliminate second row and third column, second row and third column, 1 minus 1 minus 2 0, 1 minus 1 minus 2 0 is equal to minus 1 bracket, 0 plus, and it will go again minus 2 is equal to minus 1 into minus 2 is equal to 2. Now a 3 1 minus 1 3 plus 1 m 3 1, so it will be 3 4, it will give positive. Eliminate third row and first column, minus 1 3 2 5, minus 1 3 2 5 equal to 1 bracket, minus 5 plus minus 5 minus 6, 1 into minus 11, so it gives minus 11. A 3 2 minus 1 3 plus 2 3 4 5, so it will give negative 3 2 equal to minus 1. Eliminates third row and second column, third row second column, so it will be 1 2 2 5, 1 2 2 5, 1 2 2 5 equal to minus 1 bracket, 5 minus 4, that is minus 1 into 1, so it will give minus 1. Now a 3 3 is equal to minus 1 3 plus 3 6 m 3 3, 6 is a positive, so here will give positive, 6 is the even, so it will give the positive. Eliminate the third row and third column, third row and third column, 2 1 2 minus 1 3, 1 2 minus 1 3, so you will give 1 bracket, 3 because 2, so it will give 1 into 5, 1 into 5. So we got all the number. Now we arrange it. 5 we got it. Now arrange all it. First, adjoint of a is equal to a11. a11 is 3, a12 minus 12, a13 6, a21 1, a22 5, a23 2, a31 minus 11, then minus 1 equal to 5. So transpose means the row will become column. So 3 minus 12 6, so it will become this horizontal will become vertical. So 3 minus 12 6. Next 1, these will become in this way, this row will become column. So 1 5 2 minus 11 minus 1 5. So this is the adjoint of A, that is 3 cross 3 matrix.